In this video, we're going to look at more applications of the fundamental theorem of calculus. Given f of 1 is equal to 10, f prime of x is continuous, and the integral from 5 to 1 f prime of x dx is equal to 3, the question here is to find the value of f of 5. We start by the definition of the fundamental theorem of calculus. Integral a to b f prime of t dt is equal to f of t evaluated from a to b, and that's equal to f of b minus f of a. Alright, so what we're given is integral from 5 to 1 f prime of x dx is equal to 3. We can rewrite this as integral from 1 to 5, interchange the order of interchange the limits of integration, and we have to put a negative in the front. F prime of x dx, that's equal to 3. That means the integral from 1 to 5, dividing both sides by negative 1, f prime of x dx is equal to negative 3. And that's just using the property integral from b to a f of t dt, interchange the upper and lower limits, and we get a to b, and you have to put a negative in the front, f of t dt. Alright, so what we have is integral from 1 to 5 f prime of x dx is equal to, an antiderivative of f prime of x is going to be f of x evaluated from 1 to 5. That's equal to f of 5 minus f of 1. But the integral from 1 to 5 f prime of x dx was calculated to be negative 3. So let's write that in for the left-hand side. Minus 3 is equal to f of 5 minus f of 1. F of 1 was given in the question to be equal to 10. So that's minus 10. If we solve for f of 5 is equal to, add 10 to both sides, we get minus 3 plus 10. 10 minus 3, that's equal to 7. The answer is f of 5 is equal to 7. Alright, let's look at another example. So here we have determined a function f of x and a constant c such that 100 plus integral from c to x t cubed f of t dt is equal to x to the 2/3. We start by differentiating the whole equation. Differentiate the left-hand side and differentiate the right-hand side. Why do we do that? Well, the motivation is to get rid of the integral. So we differentiate 100. Derivative of 100 will just be 0. We differentiate the integral part, integral c to x t cubed f of t dt, and we apply the fundamental theorem of calculus to do that. And we differentiate the right-hand side. We're going to use the power rule to do that. All right, so derivative of 100, derivative of constant is 0, plus, and ddx of the integral from c to x t cubed f of t dt is equal to, and we differentiate the right-hand side using the power rule. That's going to be 2/3. Subtract 1 from the exponent. 2/3 minus 1, that's negative 1/3. Now derivative cancels the integral. We're going to apply fundamental theorem of calculus. We're going to get x cubed f of x. And let's simplify the right-hand side. 2/3 x to the 1/3. Let's divide both sides by x cubed so we can isolate f of x. F of x is equal to 2/3 x to the 1/3 times x cubed. F of x is equal to 2/3 x to the, we have the same base, x, we add up the exponents, 3 plus 1/3, that's 9/3 plus 1/3, that's 10/3. So we found the function f of x. Alright, now we want to find c. So the strategy is plug x equals c into this equation, into the integral equation, so that the integral vanishes, and then solve for c. Let's do that. So we have 100 plus integral from c to x t cubed f of t dt is equal to x to the 2/3. Let's plug in x equals c. We get 100 plus integral from c to c, t cubed f of t dt. That's equal to c to the 2/3, plugging c for x. Now this integral is clearly 0 because the integral is from c to c. So that's going to be 0. We get 100 is equal to c to the 2/3. Let's rewrite this as 100 is equal to c to the 1/3 all squared. Now let's take the square root of both sides. That's 100. Raise it to the power of 1/2 is equal to c to the 1/3 to the power of 2. Raise all of that to the power of 1/2. So the 2 cancels with the 2, and what we get is root of 100 is equal to c to the 1/3. And now let's square both sides. Let's cube both sides. So let's raise it to the power of 3 and raise the left-hand side to the power of 3. Now root of 100 is just going to be 10. So 10 cubed is equal to, and 3 cancels with the 3 here, is equal to c. We get c is equal to 1000. That's the value of c. And the function f of x, we found that earlier to be, let's look at the last page. That function is 2 over 3 x to the 10/3. 2 over 3 x to the 10/3. This is the function, and that's the value of c. All right, thanks.